becomes more welcome and thank you for being here. This is a complete masterclass on KQL, the Kusto query language, and together we are going to go all the way from zero to hero. It doesn't matter if you have never written a single query in your life or if you already know the basics and you just want to get sharp for a SOC role. We will build every idea from the ground up step by step and we will not skip anything. By the end of this class, you will be able to open Microsoft Sentinel, read any log, and hunt real threats with confidence. But before we touch a single query, let's understand the world we actually work in. In any organization, every device is constantly writing down what it does, and those records are called logs. Becomes more your laptops, your Windows servers, your Linux machines, your firewalls and web application firewalls, and all of your cloud services. Every one of them produces logs all day, every day. Microsoft Sentinel gathers all of that into one central place called the log analytics workspace. And this is exactly why attackers are so hard to catch. Their actions are hidden inside millions of ordinary log lines sitting right next to everything that's normal. So the challenge is simple to say but hard to do. Find the attacker inside the noise, and the one skill that makes that possible is KQL. Here's how we'll get there. First, we'll learn every important operator on its own in plain language using a spreadsheet you already understand. Becomes more. Then we'll take those operators and build more than 20 real world security detections. And by the end, you'll be correlating data across different sources and hunting threats the way a professional analyst does every single day. Let's begin with the most basic question of all. Why do we even need a query language? Think about a single busy server. In just 1 hour, it can produce hundreds of thousands of events. Now multiply that across an entire company, and you're looking at millions, even billions of events every day. You simply cannot scroll through that. It would be like reading every page in a library to find one sentence. A query language flips the problem around. Becomes more. Instead of reading everything, you ask one precise question. For example, show me only the failed logons from this account in the last hour, and the engine hands back just those rows. That is the whole idea behind KQL. And here is what makes learning KQL such a good investment of your time. The exact same language is used all across Microsoft security stack. In Microsoft Sentinel, which is the SIM, the central security brain, you use KQL for hunting, for your detection rules, and for your dashboards. In Defender XDR, the advanced hunting page uses KQL to search across endpoints, identities, and email, and underneath both of them sits Log Analytics, part of Azure Monitor. That's the actual engine that stores all the data and runs your queries. Becomes more. So you learn this one language and it carries you across every one of these tools. Now the fastest way to truly understand KQL is to connect it to something you already know, a spreadsheet. Picture a simple Excel file of class 6 students. The whole sheet is what we'll call a table. Every horizontal line, one student is a row, also called a record, and every vertical column has a name and a type. Name holds text, class is a number, marks is a number. That list of column names and their types is called the schema. Hold this picture in your mind because data in KQL is organized in the exact same way. Tables made of rows described by a schema. The one extra thing a security table always has is a column called time generated. The timestamp of when each event happened becomes more. Let's push the spreadsheet idea one step further. Suppose you only want to see one student, Suraj. In Excel, you would click the little arrow on the name column, that's the autofilter, and tick just Suraj. Everyone else disappears. The rows that don't match are simply hidden. KQL does the exact same thing with an operator called where. You would write where name equals Suraj using two equal signs, which we'll come back to. So from now on, whenever you see where, I want you to picture the Excel autofilter. It keeps only the rows that match your condition and throws the rest away. This is the single most used operator in the whole language, so let it really sink in. Where is the filter? Before we start typing, let me give you the one mental model that makes every KQL query make sense. Becomes more. A query always begins with a table, that's your raw data. Then you add a pipe, that vertical bar character, and after it, an operator. The pipe simply means take everything on my left and pass it into the operator on my right. So the data flows left to right one step at a time. First you might filter it with where, then you might group it and count it with summarize. Then you tidy up the columns with project or sort. Each pipe transforms the data a little more until only your answer is left. That's the whole rhythm. Table, pipe operator. Once that clicks, KQL is yours. Alright, that's enough theory for now. Let's open Microsoft Sentinel, write our very first queries live, and actually watch the data respond in front of us. Becomes more. This is the logs page inside Microsoft Sentinel. This is where a defender actually hunts. On the far left, you can see the list of tables. In the center is the query editor where we type, and just below it is where the results will appear. The simplest possible query is just the name of a table with nothing else after it. So I'll type security event. That's the table that holds Windows security events, and press run. And there they are. The raw events come straight back, more than 8,000 rows in the last 24 hours. Notice the problem immediately, that is far too much for any human to read. So our job now is to narrow it down to only what matters. To narrow it down, we filter, and we already know the operator where. So I add a pipe and type where becomes more. Now watch the editor. As I start typing a column name, Sentinel pops up a little menu of suggestions. That's IntelliSense, and it's showing you the real columns that exist in this table, so you never have to memorize them. I'll filter on event ID, and here's a piece of knowledge to keep. Event ID 4688 is the Windows event for a new process was created. In plain English, a program just started. So I write where event ID equals 4688 using the double equals, which means is exactly equal to. I run it again and watch the counter at the bottom right. We just went from over 8,000 rows down to only 23. One line, one operator, and the noise is gone. That is the power of where becomes more. Filtering isn't only for numbers. Very often you're searching inside text, and for that KQL gives us string operators. The best one to start with is has. Watch. I filter where computer has our workstation name. The word has looks for a complete word inside the text, and this part is important. It is fast because the data is already indexed by word or token. There's also contains, which matches any partial substring, but it's much slower because it has to scan character by character. So here's the rule to remember: reach for has first, and only use contains when you genuinely need a partial match. There are close cousins too: starts with and ends with, and has any for a whole list of keywords. But has is your everyday workhorse, and just look at how far you've come already. Becomes more. You can name a table to pull back its raw data. You can filter those rows down with where, and you can search inside text quickly with has. That is genuinely the foundation that everything else is built on. In the next act, we'll learn to shape the results, choosing which columns to keep, creating brand new columns, sorting them, and taking just the top few. And then we'll meet the single most powerful operator in all of KQL, the one that turns thousands of raw rows into real insight. Summarize. So far, every query has handed us back big wide rows with every single column attached. In this act, we learn to shape that output, keep only the columns we care about, build brand new ones, put the rows in order, and grab just the top few. Becomes more. This is what turns a raw data dump into something a human can actually read and act on. Two operators do most of the shaping work, and it's important not to mix them up. Project chooses columns, you list the ones you want to keep, and everything else is dropped. Picture hiding all the columns in a spreadsheet except a chosen few extend. On the other hand, adds a brand new column that you calculate from the existing data, exactly like typing a formula into a fresh column in Excel. So hold on to this simple phrase: project picks, extend adds. Let's see project in action. I take our process creation events, add a pipe, then project, and I simply list the columns I want: time generated, computer, account, and activity. I run it and look at the result. Becomes more all. The extra columns are gone. We're left with a clean, narrow table showing only what I asked for. And notice project also controls the order. The columns appear left to right exactly as I typed them. This is how you make a query readable, and it's a little faster too because you're carrying less data down the pipe. Now extend. Suppose I want a simple true or false flag on every row saying whether it was a failed logon. I write extend is failure equals event ID double equals for 625. Read that carefully. The single equals names the new column is failure. The double equals is the comparison that fills it with true or false. I run it, and there's our brand new column on the right calculated for every single row. The original data is untouched. Extend only adds. Becomes more. You'll reach for this constantly. To lowercase text with to lower, to pull the hour out of a timestamp, or to label rows so you can group them later. Once your columns are shaped, you usually want the rows in a sensible order, and that's sort by. I sort by time generated and add days for descending. So the newest events come first. If I only wanted a handful, I'd swap sort for top. For example, top 5 by time generated days returns just the 5 most recent rows in one step. And when you only care about the unique values in a column, say the distinct list of computers that fired an event. You reach for distinct, order it, or trim it to the top. Either way, you are now in full control of what the analyst sees. Let's recap your new shaping toolkit. Becomes more project keeps and orders the columns you name. Extend adds new calculated column sort by puts the rows in order. Top keeps just the highest few and distinct collapses a column down to its unique values. Filtering plus shaping already covers a huge share of real day-to-day queries, but to truly turn data into answers we need to count it and group it, and that is the next act, the big one, summarize. This is the act that changes everything. Up to now we've been trimming a big table into a smaller table, but an analyst rarely wants rows, they want a number. How many failed logons from how many different IP addresses per hour? The operator that answers all of those is summarize, and once you own it, you can turn millions of raw events into a single clear answer. Becomes more, and you already know summarize, you just know it by a different name. In Excel, when you drop a column into a pivot table, it collapses thousands of rows into one line per unique value with a count beside each. That is precisely what summarize does. You tell it two things: what to calculate, for example, a count, and which field to group by account, count each group, and thousands of rows become one tidy line per account. Let's do it for real. I filter to event ID 4625, that's a failed logon, and then I write summarize failed logons equals count by account. Read it left to right, count the rows, and group that count by each account. I run it and watch what happens. Thousands of raw failure events collapse into one line per account, each with its own total. Becomes more. And look at the top row, the service account SVC bracket has 842 failures. That single number, which was invisible in the raw data, is now screaming at us. This is how Summarize turns noise into a lead. Count is just the beginning. Inside Summarize, you can use many aggregation functions. Dcount counts the distinct values. For instance, how many different IP addresses attacked one account, which instantly separates a typo from an attack. Some average, min, and max do the maths you'd expect over a number column. Make set and make list gather every value in a group into a single list. Brilliant for seeing all the commands a user ran. And argmax hands you the whole row with the latest timestamp your last seen in one line. Same operator, many powers, becomes more now. One of the most useful things you can group by is time, but raw timestamps are all unique down to the millisecond, so grouping by them directly is useless. The fix is bin takes a timestamp and rounds it down into a bucket here 1 hour. So I write summarize count by bin of time generated 1 hour. Now every event falls into its hour and I get a count per hour. Look at the result. The overnight hours hit around 300 and then 1900 hours explodes to 1200. That spike is your incident and bin is what made it visible. And here's the satisfying finish. I take that hourly summary and add one more line. Render time chart Sentinel switches from a table to a chart right here inside the logs page. Becomes more. And now the spike we found doesn't need explaining. It just jumps off the screen. Render can also draw a bar chart, a pie chart, or a column chart. This is how a single query becomes a dashboard tile that anyone, technical or not, understands at a glance. This was the big one, so let's lock it in. Summarize groups your rows and calculate something for each group. That's the pivot table of KQL. You go beyond a simple count with dcount, sum, make set, and argmax. You group by time using bin, and you turn the answer into a picture with render, filter, shape, and now aggregate. That is the core of the language, and you have it. Becomes more next. We go deeper into the data itself, dates and times, and pulling apart messy text in Act 5. We've filtered, shaped, and aggregated, but real logs are messier than a clean table. Timestamps need arithmetic. Free text messages hide the exact fields you need. Some columns are entire JSON documents, and sometimes a column's value should simply depend on a condition. This act gives you all four tools: dates and times, parsing raw text, reading JSON, and conditional logic. You've already used Ego without me naming it properly. It's been sitting in nearly every filter so far. Let's make it official now. Is the current instant. Ago T means a time span back from now. Ago 24H is a day ago. Ago 7D is a week ago. The letters are SMHD for seconds, minutes, hours, days. Becomes more between lets you keep only rows inside a date range, and start DVD rounds any timestamp down to midnight of that day. Exactly what you need when you want to group events by calendar day instead of by the millisecond. Let's use that for real. A manager wants successful logons grouped by calendar day for the last week with a readable label. I filter to the last 7 days and event ID for 624 a successful logon, then summarize logons as count by day equals start divided of time generated. I sort ascending and run it 7 clean rows, one per day each. with its logon count, and notice the weekend dips exactly as you'd expect for a normal business. That's a ready-made daily trend built in 4 lines. Real logs hide gold inside free text messages. Becomes more Linux SSH failure might arrive as one long sentence. Failed password for invalid user Bob from 2entry3.0 port 55244, and everything you actually want, the username, the IP, the port, is buried inside that string, not sitting in its own column. Three tools dig it out. Extract pulls one value using a regular expression. Parse pulls several values at once positionally, and split breaks a string into pieces wherever a delimiter appears. Let's watch extract do real work. Here's a Linux server's SSH failure sitting in syslog as one long message string, not a tidy column. I filter two messages that have failed password fast because has is indexed even on free text. Becomes more. Then I extend a brand new column, set IP using extract. The regular expression looks for the word from followed by four number groups separated by dots, an IP address, and the one means give me the first bracketed group, which is exactly that IP. I summarize attempts by say types or descending and run it. A free text field just became a ranked list of attacking IPs, with one address alone responsible for over 100 attempts. Parsing is what turns unstructured logs into something you can actually aggregate. Many cloud logs, Azure Activity Logs especially, don't hand you flat columns, they hand you one column packed with an entire JSON document. That's a dynamic column. It can hold an object, an array, or a nested mix of both. Becomes more if it arrives as plain text. Parse JSON turns it into something you can actually dot into, like properties dots called epress. And when a field is itself a list, say a list of resource IDs, MV export explodes it, giving each element its own row, exactly like Excel's convert text to rows for a cell with several values stacked inside it. Azure Activity is a perfect example. Every row has a properties column that's really a whole JSON document. I extend a new column P using parse JSON on properties, turning that text into something I can dot into. Then I extend two more columns, caller from P caller and caller IP from P caller epress, wrapping both in dotstring because a value pulled out of dynamic data should always be cast to a real type before you use it downstream. Becomes more I project just the readable columns and run it. What was one dense JSON blob per row is now four clean columns. Who did what and from where, the last building block, making a column's value depend on a condition. If as is the simplest, a straight two-way effects. Exactly like Excel's if function. If the condition is true, use this value, otherwise use that one case handles more than two outcomes. It checks the first condition, and if that doesn't match, falls to the next and the next, stopping at whichever matches first with one final default value if nothing does. And coalesce quietly picks the first value in a list that isn't empty handy when a field could come from one of several possible columns. Becomes more. Let's tag every event with a human readable severity so a dashboard could color it instantly. I extend severity using case if event ID equals 4625, label it warning, else if event ID equals 4624, label it info. Otherwise the bare final value other catches everything else. I project the readable columns and run it. Every single row, all 8742 of them, now carries a plain English severity instead of a bare number case, reads top to bottom and stops at the first match, exactly how you'd nest IFs in Excel, just far more readable. This act was about the raw material. Real logs are actually made of ego and started where give you control over time, extract, parse, and split, turn messy free text messages into real columns you can aggregate. Becomes more parse. JSON unlocks the nested JSON that cloud logs love to send you. And if and case let a column's value depend on a condition, exactly like an Excel formula. Filter, shape, aggregate, and now transform. You can handle almost anything a single table throws at you, but real investigations rarely live in one table. Next, we learn to bring multiple sources together, union, and the VLOOKUP of KQL. Join. Every investigation so far has lived inside one table, but real incidents rarely do. An attacker's failed logon sit in one table, their department sits in an HR list, and their Linux and Windows footprints sit in two entirely different log sources. Becomes more. This act is about bringing separate tables together, first by stacking them on top of each other, then by matching them side by side on a shared key. Sometimes two tables hold the same kind of record just from different sources. Windows security events in one table, Linux syslog in another, both really saying something happened on a machine. Union stacks them into a single result, exactly like copy pasting the rows from one Excel sheet underneath another. You can even union by a wildcard every table whose name starts with a pattern and tag each row with source, so you know which table it originally came from. Hold on to this one sentence because it prevents almost every beginner mix up. Union adds rows, join, which we'll meet next, adds columns, becomes more. Let's combine three different log sources in one query. I write union with source equals host table that names a brand new column that will record where each row came from. Then I list the table security event syslog sysmon. I filter to the last hour, then summarize a count by source table, run it, and I get exactly three rows, one per source, each with how many events it contributed in the last hour. Three completely different logging pipelines, one query, one answer. That is union, not comparing tables, just combining them. Join is the operator that merges columns from two tables wherever a shared key matches, exactly what VLOOKUP or XLOOKUP does in Excel. There are several kinds, and the kind you choose decides which rows survive. Becomes more. Kind equals inner keeps only rows that match in both tables. Kind equals left outer keeps every row from the left table, filling in blanks when the right table has no match. This is the one you'll use most for enrichment. And kind equals left anti flips it around. It keeps only the left rows that have no match at all, often the most suspicious rows of all. One warning worth memorizing: right join with no kind at all, and KQL quietly uses inner unique, which deduplicates your left key first and can silently drop rows you expected to see. Always state the kind. One more Excel picture before we run this for real. Imagine a small employees sheet, account department manager in Excel. VLOOKUP takes an account name, searches for it in this sheet, and pulls back the matching department. Becomes more. Join does exactly that for every row of a much bigger table in a single line. Kind lift outer employees on account. Same lookup, same idea, just applied at massive scale. Now the real payoff. I take our familiar failed logon summary account by account and join it lift outer to the employees table on account. I project account department and failures, sort by failures descending, and run it. Every account now carries its department right alongside its failure count. Notice SVC backup and Ghost HSECT show a blank department. Left outer kept them anyway because they simply don't exist in HR's employee list. Becomes more, and that blank is often the most important cell in the whole table. A failed login account with no HR record at all is exactly what Leftanti would isolate for you in one line. Frequently, an attacker guessing usernames that were never real employees to begin with. Join is general purpose, but when the second table is small, a lookup list, not another big log source. KQL gives you a lighter tool, lookup. It's built specifically for enriching rows from a small reference table, and it's usually faster than a general join for that job. Sometimes you don't even have a real table yet, you just want to hand build a tiny one inline for a lab or a quick watch list. A let statement with data build does exactly that. Becomes more, and external data goes one step further. Reading a small file, say a CSV of known bad IP addresses, straight from a URL into a table you can join or look up against. Let's build a tiny watch list right inside the query. I write let VIPs equals data table, naming two columns, account and tier, and hand type two rows. J Smith is gold, admin is platinum. That semicolon ends the let. Now from security event, filtered to fade logons, I pipe into lookup VIPs on account, the lightweight enrichment join and project account, tier and time generated. Run it, and every fade logon from one of our named accounts is immediately tagged with its tier, while everyone else, like contractor 1, simply shows a blank. Becomes more in a real SOC. This same pattern flags failed logons from VIP or admin accounts as automatically higher priority. Let's lock this act in. Union stacks rows from multiple tables when they hold the same kind of record. Join merges columns from two tables on a shared key, and the kind you choose, inner, left, outer, left anti, decides exactly which rows survive. Never leave it unstated. And for small reference data, lookup and inline let tables give you the same enrichment, lighter and faster. You can now pull data from more than one place and tell one connected story instead of many disconnected ones. Next, we make your queries reusable and fast with let variables functions and the performance habits every working analyst relies on. Becomes more, you now know every core operator in the language. This short act is about writing like a professional, naming your thresholds so they're easy to tune. building reusable pieces of logic and following the handful of habits that keep a query fast and cheap instead of slow and expensive. Let gives a name to something so your query reads like plain English and stays easy to tune. In its simplest form, it just names a single value, a scalar like a threshold or a time span. It can also name an entire subquery, so a big detection can be built in small readable steps instead of one giant tangle. And it can define a genuine reusable function with its own parameters that you can call by name from anywhere in the query or in a dozen other queries. Becomes more every let statement ends with a semicolon and sits above the query that uses it. Watch how much more readable a query gets. I let look back equal 1 a year and let fail threshold equal 10, two named values sitting right at the top. Now the query below just reads security event where time generated is after go of lookback and event ID is 4625. Summarize failures by account and keep only accounts where failures is at least fail threshold. If tomorrow you want to widen the window to 24 hours or raise the threshold to 20, you change one number at the top. You never hunt for a hard-coded value buried in the middle of a long query. This is exactly why real Sentinel analytics rules are written this way. Now let's go one step further and build something reusable. Becomes more I define failed logons by account as a function that takes one parameter, a time span called window wraps our familiar security event filter summarize pattern inside curly braces and closes with a semicolon. From here on, I can just call failed logons by account and pass whatever window I want, 24 hours, 1 hour, 7 days without ever retyping the logic. I call it with 24 hours filter to failures greater than 20 and run it. Same detection reusable everywhere and every future tweak to the logic only needs to happen once right here inside the function. Four habits that separate a fast, cheap query from a slow, expensive one. Becomes more always filter on time first, time generated after go of something. Before any other operator, it throws away most of the data immediately, so everything after it has far less to chew through. Filter early and aggregate late, cut rows down with where before you ever reach summarize or join. Reach for has instead of contains whenever you can, and indexed word match beat scanning every character of every row. And project only the columns you actually need, ideally before a join, so you're not dragging useless columns through the rest of the pipe. Four more summarize before you join. Join two small already grouped results, never two enormous raw tables. The size of what you're joining matters far more than the size of what you started with. Becomes more always state your join kind explicitly so you never get caught by the inner unique default from the last act. Use let for every threshold exactly like we just did. So tuning a detection is one line, not an archaeology dig, and format with one pipe per line. It costs nothing to write, and it's the difference between a query you can debug at 2 a.m. and one you can't. Let's put all 8 habits to work in one real detection. Excessive failed logons from any admin like account. I let fail threshold equal 15 right at the top. I filter time first the last hour before anything else runs. Then event ID equals 4625 and account has adim has not contains because it's a fast index match. Becomes more I summarize failures by account and only afterwards do I filter to failures at or above the threshold and join to employees left outer kind stated explicitly. Joining a tiny already summarized result instead of a giant raw table. Run it and this query isn't just correct, it's exactly how a query like this should be written to stay fast and cheap even on billions of rows. Every habit from this act in one working example. You can now do more than write a query that works. You can write one built the way a professional actually builds it. Let names your thresholds and turns repeated logic into a genuine reusable function. Filtering on time first and aggregating late are the two habits that matter most for raw speed. Becomes more and has over contains projecting early and always stating your join kind are the small choices that together are the difference between a query that scans your entire workspace and one that answers in under a second. You now have the complete language front to back. It's time to put all of it to work, 20 plus real detections. The way a working SOC analyst actually hunts starting now. This is the payoff for everything you've learned from here on. Every scene is a real detection told the way a SOC analyst actually thinks. Situation, task, action, result. Same star method the whole way through. Same operators you already know just aimed at real attacker behavior. Let's hunt. Becomes more situation instead of one account taking repeated hits, an attacker sprays a handful of common passwords across many accounts from one source hoping one lands. Task find any IP failing logons against 5 or more distinct accounts in the last hour. Action security event failed logons summarize both a raw count and decount of account by IP address. Keep IPs touching 5 plus accounts. Result: one address hit 61 accounts from a single IP, a textbook password spray, and decount is exactly what exposed it. Situation: dozens of failed logons on their own are often just noise. The real danger is failures followed by a success. Task: find any account with 10 or more failures that still eventually logged on successfully in the same hour. Becomes more action. Summarize two conditional counts in one line: fails counting only for 625x and wins counting only for 624x by account. Then keep accounts with heavy failures and at least one win. Result: two accounts where the guessing eventually paid off, exactly the accounts that need a password reset and a closer look right now. Situation: an hourly count can hide a burst. 19 failures crammed into 5 minutes reads very differently than 19 spread evenly across an hour. Task: alert only on tight bursts, not the average. Action: summarize count by both account and bin of time generated in 5-minute windows, then keep any window with 8 or more failures. Result: two accounts, each hit with a rapid burst, the shape of an automated brute force tool, not a human mistyping a password. Becomes more situation. One account signs in from Mumbai, then from London. 39 minutes later, no flight covers that distance in that time. Task: catch any user with two successful sign ins from different cities inside 1 hour. Action: this is sign in logs joined to itself. Every successful sign in compared against every other sign in from the same user principal name, keeping pairs with different cities and less than 60 minutes apart. Result: one account, two impossible locations, 39 minutes apart, a shared or stolen credential almost certainly being used from two places at once. Situation: attackers rarely type a plain readable command, that they base 64 encode it to dodge simple keyword searches. Task: find any PowerShell launch using an encoded command. Becomes more action. Security event ID 4688, new process name ending in PowerShell exe, then column has any the common encoding flags dash encoded command dash e result. A service account launching an encoded PowerShell command worth decoding immediately because whatever it says, it was written specifically to be unreadable at a glance. Situation: attackers love living off the land, abusing tools already trusted and already installed instead of dropping an obvious new executable. Task: flag any known LOL bin when its command line reaches out to the internet. Action: filter to process creation. New process name has any the classic lolbin list and column has any HTTP or HTTPS a certificate utility quietly used to download a payload from the internet. Becomes more completely normal binary, completely abnormal behavior. Situation: to move deeper into a network, an attacker needs more credentials. The fastest way is dumping them straight out of memory. Task: catch any PowerShell command referencing known credential theft tooling. Action: filter to PowerShell process creation. Then complain has any invoke Mimikat Sikalsa or Elsas exe. Result: one contractor account, one command, invoke Mimikatz typed straight into a live session. This account is compromised and every credential on that box should now be considered stolen. Situation: Word documents don't launch PowerShell, people do by accident when a malicious macro runs the moment they open an attachment. Becomes more task. Catch any case where an Office application is the parent of a shell or scripting host. Action: filter to process creation where parent process name has any Word, Excel, or Outlook, and new process name has any CMD, PowerShell, or WScript result. One Word document opened in HR, immediately spawning PowerShell, the exact signature of a malicious macro phishing attachment caught the moment it executes. Situation: before running their real payload, a careful attacker often tries to blind SI, the anti-malware scan interface built into PowerShell, so nothing downstream gets inspected. Task: catch any command line trying to disable or bypass it. Becomes more action. Filter to PowerShell process creation. Then command has any the known bypass strings plus the hidden window. No profile flags attackers favor. Result: one hidden PowerShell window explicitly patching AMC before doing anything else. A strong sign whatever comes next was never meant to be seen. Situation: an attacker who's finished on a box will often try to cover their tracks by wiping the very logs that would prove they were there. Task: catch it the moment it happens. Action: event ID 1102 on the security log means The audit log was cleared, union with event ID 104 on the system log, meaning an entire event log was cleared. Becomes more result, both fired seconds apart from the same admin account. Someone just tried to erase the evidence, and this alert is the one thing they couldn't delete because it fired the instant the clearing happened. Situation: an attacker plants a new file, then rewrites its timestamps to look years old, so it blends into a folder of legitimate system files. Task: catch a file whose timestamps don't make physical sense. Action: device file events, file creation events. Keep any file whose recorded creation time is actually after its last write time. A logical impossibility unless deliberately backdated. Result: one file created minutes ago but stamped as though it was 7 years old. That contradiction is time stamping, and it's a near certain sign of deliberate evasion. Becomes more situation. Once an attacker has a foothold, their next move is almost always reconnaissance, quietly mapping the network and who has power over it. Task: catch the built-in Windows commands that do exactly that action. Filter process creation to complain has any homie, net user, net group, or an L test, the standard discovery toolkit, no custom malware required. Result: a contractor account querying the domain admin's group directly, completely normal looking Windows commands used for a very abnormal purpose. Situation: RDP is a favorite door for attackers once they have any valid credential, a full interactive desktop, not just a command line. Task: find any RDP login reaching a server from outside the corporate network. Becomes more action. Event ID 4624 with logon type 10, then exclude the internal IP ranges, leaving only external sources. Result: an admin account removed desgulping into a domain controller from an external IP with no business touching that server directly, worth an immediate call to confirm it was really them. Situation: in a well-run domain, admin accounts authenticate with Kerberos almost every time. A network logon falling back to raw NTLM is worth a second look. Task: find privileged accounts authenticating via NTLM on a network logon. Action: event ID 4624 logon type 3 authentication picketing and equal to NTLM account name has admin. Becomes more result. An administrative account network logged on via NTLM to a finance workstation, exactly the pattern left behind by passed hash, where an attacker replays a stolen password hash instead of ever knowing the real password. Situation: a real incident almost never stays inside one log source. An attacker's Linux foothold, their Windows logons, and their process activity are scattered across three separate tables. Task: reconstruct one connected timeline. Action: union security event syslog and sysmon with source. Filter to a single 1 hour window on the host involved. Project to the readable column, sort by time. Becomes more result. Four events 4 minutes apart from three different pipelines: a Linux brute force, a Windows failed logon, an encoded PowerShell launch, and a suspicious outbound connection reading as one story instead of three disconnected alerts. Situation: a correlated timeline is powerful, but it's even more powerful once you know who each account actually is. Task: attach department context to every event in the timeline. Action: take the union security event and sysmon timeline and join it left outer to employees on account, the exact enrichment pattern from Act 6 now applied to a live investigation. Result: admin resolves to a real IT employee, but FVC backup and contractor 1 both come back blank. Neither has an HR record at all. Becomes more: two of the three accounts in this timeline aren't real people. That is the single most important line in this whole investigation. Situation: malware often has a name designed to blend in, but even a well disguised name usually only appears on the one machine it was actually dropped on. Task: find any process that ran on exactly one host across the entire environment this week. Action: summarize decount of computer by new process name over 7 days. Then keep only processes with the host seen on of exactly one result. Two processes each seen on a single machine out of the whole fleet. Not proof of malice by itself, but exactly the kind of rare one off process a human analyst should look at next. Becomes more situation. A compromised host reaching out to a command and control domain almost always looks brand new to that machine. It has never queried that domain before ever. Task: find any DNS query from a host that is genuinely first time seen. Action: sysmon event ID 22 for DNS queries. Summarize the earliest time each computer query name pair was ever seen. Keep only pairs whose very first sighting was in the last hour. Result: one finance workstation querying a domain it has never once contacted before for the first time an hour ago. Precisely the shape of a freshly planted C2 beacon. Situation: admin accounts usually have predictable habits, the same handful of servers day after day. A first ever logon to a brand new machine is worth noticing. Becomes more task. Catch any admin labeled account logging on to a computer it has never logged on to before. Action: summarize the earliest logon time per account computer pair. Keep pairs whose first ever sighting was in the last day filtered to admin style accounts. Result: one admin account, its very first logon ever to an HR workstation this morning, a legitimate new responsibility, or a stolen credential branching out. Either way, it's worth one phone call to confirm. Situation: Microsoft Entry ID already scores every sign in for risk using signals you'd never spot by eye, anonymizing proxies, unfamiliar devices, leaked credentials. Task: surface only the sign in scored as genuinely high risk. Becomes more action. Sign-in logs filter to the last hour, where risk level during sign-in equals high, projecting the user IP and the actual risk reasons. Result: one sign-in flagged high risk, arriving through an anonymizing IP with several unfamiliar features. Microsoft did the hard signal processing. This query just made sure nothing high risk slips past unseen. Situation: with the stolen password but no way past MFA, attackers sometimes just spam approval requests, hoping an exhausted user taps approve by accident. MFA fatigue. Task: find any user denying an unusually high number of MFA prompts in a short window. Action: filter sign-in logs to MFA denied results. Summarize the count by user and a 15-minute bin. Keep 5 or more denials in that window. Becomes more result. One user, 8 denied prompts inside 15 minutes. They know it isn't them signing in, and they're the reason this attack failed. This account still deserves a password reset today. Situation: global administrator is the single most powerful role in a Microsoft 365 tenant. If an attacker grants it to any account they control, they effectively own everything. Task: catch every new grant of that role immediately. Action: audit logs filtered to add member to role operations, where the target resource has global administrator specifically. Result: a contractor account, one that should almost never need tenant wide admin rights, was just handed global administrator confirmed and expected, or the last step of a takeover. This line needs an answer within minutes, not days. Becomes more situation. A phishing email doesn't always ask for a password anymore. It asks a user to click allow on an innocent looking app, which then reads their mailbox forever. No password needed ever again. Task: catch any consent grant handing out broad mail or file permissions. Action: audit logs consent to application operations where the granted permissions has any mail read write, or files read write all. Result: one employee, one unfamiliar third party app granted full read access to their mailbox and files. No malware, no password theft, just one click. Revoking that consent is now more urgent than any antivirus alert. It becomes more. Look at what you just did: 23 real detections across brute force execution, evasion, lateral movement, cross source correlation, anomaly hunting, and cloud identity, and every single one used an operator you already fully understand where. Summarize, decount, cative, pin, join, union. That is the real secret of KQL. You don't need 100 exotic tricks. You need these dozen operators aimed precisely at attacker behavior over and over. One act left: we bring everything together into a single deployable capstone detection, and then close out with where to practice and the interview questions that prove you've truly mastered this. Everything in this masterclass has been building toward this one query. Becomes more not a teaching example, the exact kind of detection a working analyst deploys as a live sentinel rule, using nearly every operator you've learned stacked together to tell one complete story. Situation: this is it, the capstone, the exact kind of query a working analyst deploys as a live sentinel rule. An attacker is spraying passwords. Individual failures mean nothing, but many failures followed by a success from the same source is the guess that worked. Task: first isolate the failure burst. Action: let look back equal 1 hour, let fail threshold equal 10 hour tunable knobs right at the top. Becomes more than a named subquery. Failed security event filtered to the last hour, and event ID 4625, summarized by IP address, computer, and a 10-minute bin, counting failures and collecting the accounts tried with make set, keeping only bursts of 10 or more. Result: one burst, 14 failures in 10 minutes from one IP against 4 different accounts. A spray caught mid attempt before we've even looked for a success. Task continued. Now find any success that happened after one of those bursts. Action wins is a second named subquery. Every successful logon projected down to its time, IP, host, and account. Then the payoff fails joined inner to wins on IP address and computer, keeping only rows where the success time is after the failure burst becomes more result one row. And it tells the whole story by itself. 14 failures against 4 guest accounts from one IP, and 11 minutes later a successful logon as admin from that exact same IP and host. That is not a coincidence, that is a password spray that succeeded, and every column needed to open an incident is sitting right there in this one row. Map IP address to the IP entity and success account to the account entity. Save this as an analytics rule and it fires on its own forever the next time this happens. One more thing turns this from a query I ran once into a rule that protects you forever. In Sentinel, you save this exact query as an analytics rule. Becomes more you map IP address to the IP entity, computer to the host entity, and success account to the account entity. That's what lets an analyst pivot and investigate with one click instead of hunting manually. You set a schedule every 10 or 15 minutes, matching your look back and the severity from this moment on. The exact detection you just built runs by itself around the clock and opens an incident the instant it fires. Knowing the language is only half of it, the other half is reps. You don't need a paid Sentinel workspace to practice. Any free Azure subscription gives you a log analytics workspace with the exact logs page you've used in every scene today. Becomes more Microsoft Defender's advanced hunting page speaks the identical KQL just aimed at endpoints, identities, and email instead of Sentinel's SIAM data. And if you don't have live data at all, you already know the trick. A few hand typed rows in a let data table is enough to practice, summarize, join, and everything in between. Open a query window today and just start typing. Let's make sure you can talk about this in an interview room, not just in a query editor. Why is has faster than contains? Because has uses a built-in text index to match a whole word, while contains has to scan every character of every row. What does KQL's default join do and why is it risky? Becomes more with no kind stated. It silently uses inner unique which deduplicates your left key first and can quietly drop rows you expected to see. Exactly why you always state the kind. And the classic what's the difference between union and join? Union stacks rows from tables holding the same kind of record. Join merges columns from two tables side by side on a shared key. Say these answers out loud until they're automatic 5 more. And notice the pattern. Every answer is something you already built with your own hands today. Write a query to detect a brute force attack and you can just recite exactly what you typed in. Act 8 security event ID 46215. Summarize count by account, keep the ones over a threshold, why filter on time first. Becomes more because time generated is indexed and filtering it first discards most of the data before anything else even runs. And if they ask about your process, not just your syntax, that's your moment to say the four letters that built every single example in this masterclass: situation, task, action, result. Look back at where we started. Why do we even need a query language? And look at where you are now. You can open Microsoft Sentinel, read absolutely any log, filter it, shape it, summarize it into an answer, correlate it across three different sources, and deploy a real detection that watches your environment forever. That is not a small thing. That is the exact skill that separates someone who's heard of KQL from someone a SOX actually hires to hunt with it. Becomes more go open a query window right now. While all of this is still fresh, the only way any of this becomes permanent is by typing it yourself. Thank you for spending this time with me. Now go hunt, and that's a wrap. Thank you so much for watching this KQL 0 to Hero masterclass. If it helped you, please subscribe to Cyber Talks with Goutham. Every video is built to take you from a concept all the way to a real enterprise ready skill. Hit the like button, drop a comment telling me which topic you would like next, and share this with someone who is just starting their SOC journey. And most of all, go and practice what you learned today because that is where it truly sticks. Until next time, keep learning, stay curious, and keep hunting. Thank you so much and take care.